Hi. Today I'm going to do the density lab with you. Some of us missed that day or didn't get to do it, so I want to make sure that you all get a chance to at least get the data down and understand what's going on. So this lab is about density, and I'm going to find the density of these 4 rods, and we're going to use the displacement method to find the volume, and we're going to use a scale to find the mass. And I've got water in a graduated cylinder, so why don't we just get started? And I'll move this down this way so we can see the stuff. Got my paper there, got the stuff that I need. Let me move that away a little bit more. Something like that. Let's try that. All right, so here's my scale. All right. There's my water. There's my cylinder. Just getting everything in order here. There are the rods. That's my worksheet. Okay, so first of all, of course, put your name on it. All right. And we're going to fill in the unit for volume that we should understand is milliliters. M-I-L-L-I-L-I-T-E-R-S. I hope that pops up okay for you guys there. If you can't see it very well, I'm sorry about that. Okay. And then the volume of water measurement, what I did earlier was I placed 15 milliliters of water in here, and I used a dropper to get it exactly. I put a little bit too much in, so I pulled it in there, pulled it out, put it back into the cup, and I got it pretty close to exactly 15 milliliters. One thing about this cylinder is that it goes by 1/2 milliliter. Each line is a half. Some people thought it was 1, but it's a half. Okay, so there's that. And the first thing, and the volume of water measurement, we'll put that there, 15 milliliters. Okay. Mass measurements, the unit for mass is grams, G-R-A-M-S. So go ahead and write that in there. And now I have to find the mass of these different bars. First one is the light silver bar. I'll turn it on, make sure it's in grams, and make sure it's at 0, and it is. So I take my light silver bar, I put it in there, and as you can probably see, it says 18.2. So I take my pencil and write 18.2. Okay, that's the mass of that. Short and sweet. And then the heavy silver bar, there's that. It looks the same as that, but it feels much heavier, all right? It's also rusted on the ones that you saw, I believe. The heavy silver bar weighs 49.5. So I take my pencil, I write 49.5. There it is. Put that away. Next one is the gold bar. Grab that, put that on there. The mass of that is 53.8. 53.8 grams. Okay. And the last one is the brownish red bar. Put that on there. And that weighs 56.5. So 6.5 grams. All right. These 3 are kind of similar. That one is much different. All right. Now back to volume. Again, the unit for volume is milliliters. Lovely. There it goes. I'm going to the next page. Now I have to write instructions. It says, how can we find the volume of the cylinders? Write the steps below. We did this the other day where we used a object that couldn't be measured, and we put it into the cylinder, and we wrote a procedure on that. Okay, so we're going to do that again here, and here's what we're going to write. Let's make sure I got it. I don't want to deviate too much from what I wrote before, so I'll open this up, see what I got here. All right, so 1, and steps are when you use numbers or dots or something to let you know that the next step comes up. So 1, put 15 ml of water into a cylinder. Oh, geez. Messed up the spelling. My fault. Okay. And step 2. Put a rod into the cylinder. Note the new volume, because it'll go up. The rod pushes the water up, and that's what we call displacement, when it pushes the water up. Number 3, subtract the new volume by the old volume. Okay? Not super difficult. We should be able to do something like that. We should be able to write down the procedures. I only have 3 steps. Number 1, put 15 milliliters of water into a cylinder. 2, put a rod into the cylinder and note the new volume. Number 3, subtract the new volume by the old volume, and that gives you the volume of the rod. Okay. So next, we have to do that to each of these. All right. There's my cylinder. I start with the light silver one. There it is. I gently slide it in as such. Very gently. There it is. I didn't even make a splash. That's amazing. And it says 21.5. So my lightweight silver bar is 21.5 milliliters. Okay. Now to get it out, just put your finger over the hole and pour the water out and get the silver bar out and dry it on a paper towel. Yay, nice and dry. Okay, put it back in the slot. Second one is the heavy silver bar, so I grab that. Okay, make sure I got it. Oh, there's that. Oh, wait a minute, I'm sorry. There it is. And I put 15 milliliters in again. Woo! Pretty close. And you got to get your head on it to make sure that you're right. And I'll use my dropper. I put it in just a smidge too much. There it is. Put that back in the cup. Put the silver bar in, slide it gently, no splashes. Amazing, amazing. Oh, and it's 21.5 again. How about that? 21.5 milliliters. Okay. Now here's something that I'm going to tell you that I didn't tell you the day that you were doing this, is that all of these bars are the same size. That means that they have the same volume. So we don't really have to measure anymore, at least not here and now, because I'm doing this and I know that, and I just told you that they're the same volume. So we're just going to write. Oh, I forgot something. Yep. See, they're all 21.5. But we have to do math, and we have to subtract 15. Okay? So that makes our volumes all 6.5 milliliters. 6.5 milliliters, all the way down. Okay, great. And I also have to find the density, and to find the density, I gotta do math. Where's my calculator? There it is. All right, so I got my calculator. Hopefully I can get it open. Apparently not. Well, I'll use the little one. Here we go. Okay. And the formula for density is mass divided by volume. So I use my calculator. I take my masses. My lightweight silver bar was 18.2. So I'm going to do that 18.2 divided by 6.5. So let's see what we get. $2.8 grams per milliliter. Okay. All right. And the next one is the heavy silver bar, and my heavy silver bar weighed 49.5, so I'll do that one. 49.5 divided by 6.5 equals 7.6. So big difference in the density of those two because the heavy silver bar was so much more massive. Okay? In the gold bar, 53.9, so I clear it. And I take 53.9 divided by 6.5 equals 8.29. I'll call that 8.3. Okay? A little bit heavier, a little bit more density. Okay? Next one is the brownish red, which is 56.5. Whoops, what am I doing? That's the mass. Take 56.5 divided by 6.5, and that gives me 8.7. All right? So now, as you see, as the mass went up, the density went up. That's the most dense. This is the least dense. So which one is the most dense? That's the brownish red bar. There it is. Okay? That's what we got. Very good. Next page. A couple of questions. Little conceptual questions. Making sure you understand. All right, the cylinder on the left represents the gold bar. So this is gold, GB. Okay? The cylinder on the right represents the light silver bar, L. Is that right? Is that an L? Yeah. LSB. Okay. And we're going to draw small circles in each to represent how the atoms are packed into each of the cylinders. Well, this one, the gold bar was the most dense, or more dense, much more dense than the light silver bar, which means that the particles in there, there's going to be more of them for one thing, and they're going to be closer together. Okay? More closer together. They're both going to have about the same size, but this one's going to have them closer together. You guys see that? And then on your light silver bar, same size, but farther apart. It is less dense. The particles are not as packed together, all right, as the other one, like that. So this one's more dense, that one's less dense. Okay. If we melted the light silver bar and put the other 3 bars in the liquid, I'm on number 2 here. So my light silver bar's that right there, all right? Where would the bars go? And why do you think that would happen? So first of all, this is the least dense. That's this right here. It's the least dense. If I melt it, let's say I have 100 of these. I melt it and I put it into a bowl. I would have a liquid mass of, well, this is aluminum, of liquid aluminum, molten aluminum. Be very hot. We're talking about 800 degrees Celsius, very hot. But let's say that I put these in, these other ones. Well, I know that they're not going to melt right away. It won't melt right away. Some of them have melting points that are quite high. This one has a pretty low melting point. So they will not melt, we'll say, because that's not the point of this. The point is that they will sink. And the answer, the reason why, is because they're more dense. Okay? So, conceptual question, making sure we understand what this is all about. So we would say, where would the bars go? They all would, oh God. Would sink because they are more dense. All right? And that's it. That's all you need. Okay? So get that done. Turn it in. Get points for it. All right. And I'll see you later. Okay. Bye-bye.